So in the previous segment, we have seen how to implement the customers portion of our example API. So now we are going to implement the remaining resources. So if you are following along, I'm going to ask you to change the code and check out a new version from your repository. So you can do this along with me. We are going to work with version 0.2 now that is going to add the additional resources. So now we have still an api.py, but this is an updated version with the resources for orders, items, and products. So let's see what we changed here. If we look at our customer model, this is largely the same as before, but now we have more models in our database and we have to create the relationships between them. So you probably understand what the relationships are from my API diagram. We said there that, that we have customers that have many orders, and orders that have many items, and items that have one product each. So I have implemented all of that in Flask SQL Alchemy. So here you can see that for my customer model, I added a relationship. This is a one-to-many relationship for orders. Now I have the get URL the same. In the export data, now that I have all the additional support for the additional resources, I can now add my second link in this resource representation. So my orders URL, I can generate it again from URL 4. And as always, I'm using external to make sure that the URLs that URL 4 generates are fully qualified. By default, URL 4 will generate just the path portion of the URL. So when working with APIs, since the API will have no context, it's best to provide the full URL. Import data does not change because this new attribute, orders URL, was a read-only attribute, so our representation when it's coming in from a client is the same. So here we have our product model. So this is largely similar to the customers model that we've seen before. Here we have a model with ID, name, and the relationship to items. We have a get URL that returns the URL for itself. We have an export data that generates the Python dictionary that we will use as representation. And we have an import data that takes representation from the client and uploads all the data elements into properties in the model. We continue to use exception handling to avoid having to do error checking in the routes. Whenever this fails, we raise an exception, and that will stop the flow, and we don't need to worry in our routes to do any error checking. Here is the order model. The order model is a tiny bit more complex only because it uses a date, and working with dates and APIs involved a little bit of complication. So we have an ID, customer ID. This is a relationship to the customer. We have the date, and we have a relationship to the items in the order. Get URL is the same. Export data needs to export 3 resources. So self URL, as always, link to the customer, which we obtain by using the relationship, and that will give us the model that's related. And from then on, we can use the get URL auxiliary method. Items URL is generated from the route. So we are going to see in a little bit how this route works. And finally, we have the date. And for the date, I decided to go, as I mentioned in the demonstration, with the ISO format for dates. And for that, I'm using the ISO format method of the datetime class, which in this case, because this is an object that doesn't have a time zone associated with it, comes without the time zone. So I need to add the Z to make sure that this is registered as a UTC time zone object. In the import data is where a little bit of complication exists to convert that date that is given by the client into a date that we can use in our object. So let's see what the problem is here. The date will come as a string. I need to use an auxiliary module called datetime parser because the Python standard library does not parse ISO times, unfortunately. It's unfortunate that you can export them, but you cannot import them. So I, using an auxiliary package that I imported and you have in your virtual environment because it was in the requirements file. So datetime parser will parse the string and return a datetime object that has time zone in it. But I think it's not a good idea to store time zones in our database. To be consistent, our database will have to have all times in the same time zone. As I mentioned in the demonstration, for this API, I decided to use UTC time zones in my database. It's very important that when you store times in your database that you use a consistent time zone. So you can pick any time zone that you want, but it needs to be the same. Because it is the same, there's no need to store it in the database. You know that the time zone is the same, so all you need to do is store the date and the time zone is known. So when we use datetime parser to parse an ISO date coming in a string, that will return a datetime object that has a time zone in it. So the client could send the time in any time zone that it wants. It can send different time than the one that we want. If you look at the Python datetime API documentation, you will see that there's the concept of naive and aware datetime objects. So the naive datetime objects are those that don't have a time zone associated with them. The aware objects are the ones that do have a time zone associated with them. When we invoked the datetime parser package and get a datetime object in return, that is an aware datetime object, and we need it to be naive because we don't want to store the time zone in the database. So I need to do a little bit of manipulation here to convert this aware datetime object, which could have any time zone, because we are going to allow the client to send times in any time zone. That's required. That's very important. And we are going to convert it to UTC, and I do that with the as time zone, passing TZ UTC as an argument. So this returns the time converted to a UTC aware datetime object. The last bit will remove the time zone from the object. So now we have a naive datetime object that is ready to go in our database. Following this, we have the item model. This model has links to the order ID. So this is one of the relationship that it has. It has a relationship to the product, and then it has the quantity, which is an integer. We have the get URL. The export data doesn't present any challenges. We can generate all the items in the representation from auxiliary methods that we have in this or other models. And if we look at the import data, here we do have a little bit of trouble. We need to take the product URL, as you remember from the demonstration, and convert that into a product that we can link and create a relationship to. So this is a place where Flask unfortunately cannot help. One of the things that Flask cannot do is take a URL and tell us what resource it represents. It has all the information to do it, but there's no public way to generate the reverse. This is basically the reverse of the URL for function. Now we have a URL and we want to know what resource it represents and what ID in particular is the URL referring to. So what I did to overcome this limitation is I created an auxiliary function that I called split URL. And this function does the job that Flask currently cannot do. So when we call split URL and pass a URL that we have a route for, split URL will analyze it, look at the URL map that Flask has and that it built based on the decorators, the app.route decorators. And with that, it will return the endpoint name and the arguments that generate that URL. So this is exactly the reverse of URL 4. If I send this to URL 4, I'm going to get back the URL that I started with. So here I generate my endpoint and my arguments, and I also parse my quantity and store it in my quantity property. If I get a key error, that means that I either don't have the product URL or the quantity. Either one that's missing will trigger an exception, and that will stop this, and the client will get an error. Now, if there were no errors, I need to make sure that the URL that was sent was a product URL. So I check that the endpoint is getProduct, and I make sure that the arguments have an ID item in them. So if either one of those is not there, I have another validation error. And I raise the validation error, and I put a message saying that the product URL is invalid. Now I know that I have a correct product, and I have the ID because it was parsed. So now I can issue a query to my database and get that product object. I assign it to my property, and that will establish the relationship. If the query for some reason returns none, which it shouldn't, but if it does, then that means that the client sent a product that doesn't exist, and that will be also a validation error. The split URL function that I'm using here is stored in a module called utils.py that you can find in the same directory where this application is. You're welcome to review it. I'm not going to show it here, but it will give you some idea of how Flask URL maps are handled. So that is it for the models. Now we can look at the routes a little bit. So we have the customer routes, we haven't changed. Here we have product. So product, we can get the collection. This is built exactly in the same style as the customers. Same for the individual route, the one that returns a single product. That's identical. We have a post to create a product. That works exactly the same way. And we have a put to modify a product. Again, it's all the same. This is greatly because we have a collection of helper methods in our models that do all the hard work. So here, when we get to the routes, we really don't have much to do. This is very simple, and this is actually the way I like it, because the routes are the places where you do most of your work, and you want that code to be readable. You want to return to this a year later and be able to read it and understand it right away. So for orders, we have a similar setup here. We return the collection, we return individual orders. We have a get and a post. Here we have a particular one. If you remember from the demonstration, to add an order, we did not go through the public orders URL. That URL did not support a post request. The only way to create an order was to use the orders URL that was returned from a customer representation. So this is the route that does that work. Here we have customers. We include the customer ID, and then /orders/. I ended in / because this is a collection. And here I bring my customer from the database. I create a new order, and I set my customer so that the relationship is established. I import the data and write it to the database. So it's pretty similar to the others that we've seen. We have a put to modify an order. Here we have a delete. We haven't seen a delete before. So orders, we allow them to be deleted. So we get the ID and we grab it from the database. Again, we continue to use get or 404 so that we don't have to check for errors here. If we get an order, we delete it from the session, and then we commit the session. So it's interesting to note that when an order is deleted, the order may have items associated with it. So we want to delete all the items along with the order. And you can see that here I don't worry about that. I just go ahead and delete my order. The way this is done is in my relationship. So in my order relationship, I set a cascade instruction so that when the order is deleted, all the associated items will be deleted along with it.